So welcome to 4K's level of physics instant calculations. We're going to attempt here a question from a past exam paper under the topic of gravitation. So the question reads here: the orbit of the Earth, mass 6.0 times 10 to the power 24 kilograms, may be assumed to be a circle of radius 1,5 times 10 to the power 11 meters, with the sun at its center as illustrated in Fig 1.1. So I want you to look at that diagram. I hope you can see it clearly. Okay, so the question says here, we're given more information here. The time taken for one orbit is 3.2 times 10 to the power 7 seconds. Question number A, calculate the magnitude of the angular velocity of the sun, of the Earth about the sun. Okay, so let's go about the calculations. I also want to make this announcement that will be in Glendale, Mashonaland Central. So if you're in Glendale, you can contact me for lessons. So we're going to be in Glendale over the holidays. We're going to be in Glendale. So make a date with us and let's do this. So I'm going to take away all these variables. We're going to be having all these smart learning tools available. So let's do this question together and see what we come up with. So you're told here we're going to enter the variables that we're given here. You're given the mass of the Earth. You're given the mass of the Earth, which is 6 times 10 to the power 24 kilograms. You're also given the radius, which is the distance between the Earth and the Sun in this case, and it's 1.5 times 10 to the power 11. What are you also given? You're also given the time taken for one orbit to complete, which is your period. So you're given a period of 3.2 times 10 to the power 7 seconds. So with these variables, you can be able to calculate a lot of things. All these variables here can be calculated just from those 3 variables. So it's a lot you can do with just those 3 variables. So here we are being asked you to calculate the magnitude of the angular velocity of the Earth about the Sun. So we are interested here in angular velocity. So here it is. Let's look at the calculation there. So period velocity equation. So you can calculate your velocity from that equation, and you can use the tangential velocity equation. You substitute your velocity and you can calculate there. You're given the radius, so you can calculate your angular velocity from the tangential velocity equation shown there. So we have our answer is 1.962 times 10 to the power 7 radians. So this is what we are supposed to do. Let's go to the next question here that says, so the next question says here, calculate the magnitude of the centripetal force acting on the Earth. Centripetal force. So let's look at what equations you can manipulate. Again, period velocity equation, and then you get your velocity. With your velocity, you can use the centripetal force equation there, where you substitute your velocity, mv squared over r. You're given the mass, you're given the radius, and now you have a velocity. You square it, and you get a centripetal force of 3.466 times 10 to the power 22 newtons. So this is how you go about the calculations. Let's look at the last question that you can calculate using just these 3 variables. So the other question here says, so we're asked the magnitude of the angular velocity, the magnitude of the centripetal force. The other question is determine the mass of the Sun. So the mass of the sun, this would be your orbital mass. So what can you do to find this mass? Let's look at the equations that you're supposed to use. The period velocity equation is coming up again so that you can calculate your velocity. What do you do with the velocity? You substitute into the planetary motion equation shown there. Gm times m naught over r squared is equal to mv squared over r. So here you can see that those two terms can go, the large m can go, and here you have your velocity squared, which you just calculated on top there. If you square it divided by the radius and r squared the other side there, you do the manipulations there, your algebra, and your answer is 1.949 times 10 to the power 30 kilograms. So I'd like you to do these calculations on your own, see whether you're able to recall these equations and manipulate them. So make a date with us. We'll be available. You can contact me on the numbers provided. You can join our WhatsApp groups, our online seminars groups. You can join our paid groups for lessons. So let's meet in those groups. See you in the next video.